Hello guys, Assalamu alaikum. Today I am here with a system design tech talk on chat application. I will start by showing the high level system design of a chat application in both normal mode and incognito private mode. So I will start by showing the basic high level design of the chat application when it has fewer number of customers and when the application uh, grows its customer base, when the traffic increases, how we can scale the design. These will be very basic discussions. So let's get started. The diagram you are looking at is a very high level system design of a chat application when it has a small traffic and less number of users. By this diagram, I am demonstrating to you how the chat application system design will look when it is an incognito chat. By incognito, you understand that it is a private browsing type thing, that user data, user history should not be saved. So in this diagram, you can see there is no database component. There is just a front-end application, which can be React, Vue.js, or anything. There is a backend server application, which can be any backend API. And there is WebSocket connection in between, which means through the help of the WebSocket connection, these number of users are chatting or talking in between themselves in real time. And as this is an incognito chat, which means the browsing data, the messages should not be preserved. So this diagram has no database connected. It is the most simplest diagram I think I have drawn. So now we will look at what a normal chat design looks like. In the normal chat, you can see in the diagram, this is almost the same thing that we saw in the previous diagram. There is also the user base, a front-end application, a back-end server application, and a WebSocket connection in between. But one thing extra here you will notice is the database, which was not in the previous diagram. Why? Because as this is a normal chat, it is not in incognito mode, we must preserve the data. Whatever the users are sending from front end to back end, the messages must be saved in database. So we are persisting the data and it is a normal chat now. So what happens when the user base grows? Like, let's say the chat application has become very famous and there are so many users that the single server is unable to take the load. You know that in such scenario, scaling comes in. So now we will look at what happens to our chat application system design when we horizontally scale it. I repeat, it is horizontal scaling. So let's go to our next slide and investigate the scenario. What happens on horizontal scaling the chat app system design? We can see the number of users have increased so much from 100 to it can be thousands or millions. So we are telling it is high traffic, many users. So now instead of one server, we had installed a multiple number of servers. It can be 2 to 10 or more. And now there is a load balancer in between the servers and front end. So whenever a user wants to send a message in Facebook, let's say, the front end doesn't know which of the server it is communicating with. It just knows that it is sending the message to the load balancer, and the load balancer will pick any of the server for this user guy. So let's say 2 or 3 friends wants to talk to each other. Person 1 sends a message, hi, and this message is and for this message, the load balancer has chosen server 1. So server 1 has received message hi. And we can see person 2 wants to send message, hello, how are you? But when the person 2 is trying to send a message, now the load balancer has picked up server 2 in round robin fashion or maybe by some other algorithms. And when person 3 is trying to send another message, there is some urgent news, the load balancer has picked the server 3 by its internal algorithm. So what happens is these three people were supposed to talk to each other in a single group, like our messenger group we see. But due to horizontal scaling, the messages have been sent to different servers. So neither person one is watching the message of person two and three, neither person two is watching the messages of person one and three. So what has happened that our system has broken. Our messages have splitted into a number of servers where they should have been in a single server. So I am telling that incognito chat with many users ruined. By incognito, I have told you that there is no database, there is only server and front end. And as the servers are horizontally scaled, no single server has the collection of all the messages in a group. So our chat application has successfully broken when we scaled it. So now what is the solution to it? How can we come to a solution which will help us solve the problem? The first thing that came to my mind is database. Let's store all the messages in some store. It can be SQL or no SQL. That's not the debate for today's session. So let's see what happens when we install a database in the system. So many users are using the front-end app to send their messages to the load balancer. The load balancer is picking any of the available servers and propagating the message. So each of these servers have a partial set of message, and every server is saving the message to a single central database. So what happens is, though each of these servers have a partial set of data which is incomplete, this database contains all the data. You can see here, this database has the centralized sequence of the messages one by one. But still, I will say this is not the solution we are looking for, because this is not a good design that in a chat application, we will hit the database every millisecond that give me the latest data, give me the latest data. Again, server 3 is telling give me the latest data. This is a very bad design to every time, every second hit the database multiple times to retrieve the latest set of data, because no one has the latest alone. So what can we do in such case? When thinking for this solution, what comes to my mind is message queue, because we need something that will notify all other available servers that I have a new message. For example, when server 1 received a message, hi, then server 2 and server 3 also should know that there is a new message called hi in some other server. So to mitigate the situation, I have introduced a message queue in my design. Now let's look at it. Let's look how it looks. Now you can see there is one more component in the design, which is RabbitMQ message broker. If you don't know about RabbitMQ, it is a message bus. By this message broker, we can propagate messages from one server to another server in the backend side. And RabbitMQ has different ways of sending message. For my system design, I am choosing fan out type for now. By fan out, I am telling fan out exchange broadcast any message to all active subscribers upon received without storing. So what fan out does is, whenever RabbitMQ fan out exchange receives a message, it instantly propagates the message to all the available subscribers. So when the front end will send server 1 that I have a message called hi, and server 1 will send the message to RabbitMQ fanout exchange. What will happen is this RabbitMQ exchange will propagate the message hi to all of the servers, including server 1 who sent it, because fan out exchange has no idea who sent me and where should I send it. It will just propagate to everywhere. So though server 1 received hi, with the help of RabbitMQ fanout exchange, now server 2 also knows there is a new message hi, server 3 also knows there is a new message hi. Again, when front end sent a message, hello, how are you? And the load balancer propagated the message to server 2, the server 2 is sending the message to RabbitMQ message broker, and RabbitMQ, just like a fan rotating in all directions, it is throwing the message to every available server right at that moment. So again, all the servers have received the message, hello, how are you? So what RabbitMQ fanout exchange is doing here is, it is letting each and every available server get the latest message received in any of the servers, so that I can say, be it server 1 or server 2 or server 3, it has the collection of all the messages. So whenever 2 or 3 people wants to talk to each other, and one people connects with server 1 under the hood, another people connects with server 2 under the hood, and they are sending their messages to different servers. RabbitMQ is helping me to synchronize the message in each and every server, so that every server has the latest set of messages without any message lost. So this is how, by incorporating RabbitMQ message broker, we are solving the problem of horizontal scaling that came with horizontal scaling into the system design. And uh, initially we started with incognito chat, you can see. So if you want to build an incognito private mode chatting system, and that should be horizontally scaled, then what we will have to do, we will have to just remove the database, don't save any message to the database, because that's the purpose of incognito mode messaging. So front end will send the messages to any of the servers with the help of load balancer, and each of the servers will notify all other servers about the message with the help of RabbitMQ. That's it about incognito horizontally scaled chat server. But when you are coming out from incognito to normal mode, you just need to add one more step, which is saving the message to database before propagating to RabbitMQ. So of course, whatever I have told in today's session is not everything about system design in a chat system. There are much more to it. There are much more complex scenarios, like there can be caching, there can be other concepts. But today's video is up to here. If anyone have any feedback or improve or corrections, feel free to notify me. Thank you.